Alright, so we're going to continue with normal distributions in Chapter 2, Section 2. And you have seen these 4 steps before in Chapter 1, but we really didn't talk about them much. But I did tell you they were going to appear throughout this course. So let's look at how this applies to normal distributions. So when you are trying to solve a problem involving normal distributions, the state portion will express the problem in terms of the observed value, the observed variable x. You should always state what x equals. You should never use x or write down x unless you have stated what x represents in the context of the problem. Then you're going to draw a picture and show the area that you're trying to find the proportion of. So just draw a bell curve and draw your line at the value that you're looking for, and then shade either to the left or to the right of that value. The do section will be actually performing the calculations to standardize x, and then find the proportion according to z using table A. Once you've found those numbers, you're going to write a conclusion, and it should always be in the context of your problem. So we're going to look at an example about Tiger Woods. It says when he hits his driver, the distance the ball travels follows a normal distribution. The mean is 304 yards and the standard deviation is 8 yards. We're looking for the percent of Tiger's drives that travel at least 290 yards. When we do the state plan do conclude, it does get a little repetitive because you're kind of repeating what is stated in the problem. You need to clearly define your variables when you're going to be writing them in your calculations. So the first step would be to define what x is. So x is the distance that Tiger's ball travels. And x has a normal distribution with a mean of 304 and a standard deviation of 8. When we're doing the mean of x, we just do mu with a subscript of x, and then sigma with a subscript of x to represent that they are the mean and standard deviation of the distance that Tiger's ball travels. So what we're looking for is the proportion of Tiger's drives where x is greater than or equal to 90. Don't stress about the equal to. It's not going to change your answer whether you do equal to or not equal to. The answer will still be exactly the same. So that's not really important in this problem. So now you're going to, for your plan, you're going to draw a bell curve. 304 should go in the middle, and then you can draw your standard deviations out from there. Then we'll draw a line at 290 and shade to the right. It'll look something like this. So you can see that 290 falls between 1 and 2 standard deviations to the left of the mean. And then we shaded all of the bell curve to the right of that line. So to find that area, the first thing we need to do is find the z-score at 290, because we can't use table A without first finding our z-score. So we're going to take 290, subtract 304, and divide by 8. And we get negative 1.75. So that's the standardized value of 290. Once we standardize it, we're looking for the probability that z is greater than negative 1.75. To find this, you should turn to Table A in the back of your book. It'll be the first page of Table A. Look on the left side for negative 1.7 and look on the top for 0.05. And then scroll down and across until those two meet, and you will find the number 0.0401. Well, since this table A is always to the left and we're looking for the right side, we're going to have to subtract that value from 1. So it's actually going to be 1 minus 0.0401. So our conclusion is about 96% of Tiger Woods' drives on the range travel at least 290 yards. Let's look at another problem, and this one is just, we're still talking about Tiger Woods. We're looking now for the percent of his drives that travel between 305 and 325 yards. We've already stated what x equals in the previous problem, so we're not going to restate that. But we do want to, part of our plan, our state, is to say what we're looking for. So we're looking for the proportion of Tiger's drives where x is between 305 and 325. So our plan is a sketch of this. It looks something like this. 305 falls just to the right of the mean, and 325 falls pretty far out into the tail. And then we shade between them. So to find the area between this, the first thing I need to do is standardize both values. So I'm going to standardize 305 and standardize 325. So you can see my work here. I took each value and I subtracted 304 and then divided by 8. So the standardized value of 305 is 0.13 and of 325 is 2.63. So my next step is to find the area to the left of each of these values. So the probability that z is less than 0.13 and the probability that z is less than 2.63. So for the first one, I'm going to go to 2.6 on my table A on the left side and 0.03 on the top and find where they meet. They meet at 0.9957. Then I'm going to go to 0.1 on the left and 0.03 on the top and find where they meet. And they meet at 0.5517. When I subtract these values, I'll get the area between them, and that's 0.444. So my conclusion is about 44% of Tiger's drives travel between 305 and 325 yards. One more example, and this one's about cholesterol for 14-year-old boys. Their blood cholesterol is approximately normal with a mean of 170 and a standard deviation of 30. What is the first quartile of the distribution of blood cholesterol? So this one's a little bit different. It's not asking you for the percentile or the percentage. It's asking you for the actual value of a certain percentage. So the first quartile, if you remember from chapter 1, is at the 25th percentile. 25% of the data will fall below the first quartile. So we know our percentage, and we're going to have to work backwards to find the value of x. So our state, we're going to let x equal the cholesterol level, and I probably should have said in 14-year-old boys. And then we're going to state that it has a normal distribution. You should always indicate that you realize that the distribution is normal. And then we use the abbreviation here, the capital N, with the 170 and 30, stating that 170 is the mean, 30 is the standard deviation, and that we know that the first quartile is the value of x with 25% of the distribution to its left. So that'll look like this. We have a bell curve. 25% falls somewhere in the first standard deviation to the left, and we don't know the z value. So that would be our first step, would be to solve for z, or to find z. We're going to go to table A. This time we're going to be looking at the numbers in the middle. You're going to find the values closest to 0.25. It may be 0.24 something or 0.25 something, but whichever one gets you closest to 0.25. So you should find it, and when you go over to the left and go up, you're going to find negative 0.6 to the left and 0.07 up. So that means z equals negative 0.67. Once we know what z equals, we can plug into the formula for Z. So negative 0.67, that's Z, equals X, which is what we're looking for, minus the mean of 170 divided by standard deviation. At this point, we would just solve for X. We would multiply by 30 and then add 170. You should get the value of 149.9. So our conclusion would say the first quartile of blood cholesterol levels in 14-year-old boys is about 150 milligrams. The last thing I want you to do is to check your understanding on page 124. So take a minute and pause the video and go through these, and then we'll go over the answers. All right, so I'm going to give you the answers. I'm not going to go through all the work. If you have a question about one of these or you didn't get it right, just jot it down and we'll go over it in class tomorrow. But number one is 1% of 14-year-old boys have more than 240 milligrams of cholesterol. Number two, 14.9% of 14-year-old boys have cholesterol between 200 and 240 milligrams. And three, a ball would travel 310.72 yards to be in the 80th percentile of Tiger Woods' drive lengths. Again, if you have any questions about anything we went over, just jot it down and we'll go over it in class.